Cox proportional hazard regression and survival time analysis. Survival analysis is the analysis of time until an event occurs. So it is an analysis of the duration of time till events occurs. Events can be any condition such as death or cured from disease or having disease or having an infection and so on. For the analysis, the survival data should contain at least two essential variables. These variables are the core variables for the survival data. The first variable is the time variable, which is the time from the beginning of the study to the death or the end of the study. The second variable is the event variable, which is in cases can be the death, in which it is given a value of 1 and it is failed, or as value of 0 which is censored. Survival time analysis could include only a univariate analysis. This univariate analysis is a non-parametric method. Examples are Kaplan-Meier's survival curves and log rank test. So those two methods are univariate analysis, which means that both analyze survival time based on only one risk factor, and both are used when the predictor or the independent variable is categorical. Thus, it cannot be used for continuous predictor such as age, height, weight. However, it can be used for predictor that is categorical such as gender. There is a multivariate statistical analysis such as the Cox proportional hazard regression analysis. The analysis is survival analysis method. It is a semi-parametric method, and it is used when there are more than one variables or more than one predictors. So this Cox regression only used when there are more than one predictors, more than one variables, and that's why it's called multivariate statistical analysis or modeling. So it can be used for continuous predictor such as height, weight, and age. So when there is a continuous predictor in the data, then the Kaplan-Meier survival curve or the log rank test cannot be used. Only Cox regression will be used. The regression can be used also for categorical variables, or it can be used for multivariate, such as a combination of different predictors that are continuous and categorical. The regression assesses simultaneously the effect of several risk factors or several predictors, whether they are continuous or categorical, on the survival time, and it will examine if the risk factors or factor will influence the rate of an event occurrence, such as death at a particular point in time. So the risk rate is referred as hazard rate or ratio. The analysis of Cox regression will investigate association between the survival time of individuals or patient or persons with one or more predictor variables. It will build a survival model that can predict the probability of a specific event, such as death or a developing disease, an event that happening at a particular time. Here in this slide, I had inserted a data for 5 variables. The first 2 variables are the time, survival time, and the second variable is the event. So those 2 variables, the time and the death status, are the essential survival time variables. Time is measured as a year or in a year unit, as it is the time of an individual entry into the study or until the events occur, in this case which is death, or until the end of the study. So the first individual survived for 4.6 years or year, and the second one 2.5, and the third one is 1 year survival until the event happened or until they left the study. The second variable, which is the event, is the death, as a death here given a value of 1 and still alive is given a value of 0. So these 2 variables are the survival data variables. And here we have a data for a disease which is cancer, and the event is a death. And then we have 3 risk factors or 3 predictors: the drug, the sex, and the age. The drug is categorical variable that have 2 classes in it, drug A and drug B. The sex or the gender is also binary variable that have 2 levels in it, males or females. And the age variable is a continuous variable. So we have here 2 categorical or 2 binary variables and 1 continuous variable. To examine whether there is association between all of these risk factors and the death over time, whether there is association between taking drug A or taking drug B, or males to females are associated with death over time, then Cox hazard regression will be performed. In this next slide, a table has been extracted from Cox regression for the previous data, and the 3 risk factors, which are the drugs and the sex and the age, were tested whether they are associated with the risk rate of death over time for those who participated in the study and who have cancer disease. And the T stands for survival time here. This stands for hazard ratio, and then a p-value is given here, and a 95% confidence interval for the hazard ratio. The table, the most important value to consider in the table: the hazard ratio, the p-value, and the 95% confidence interval. To interpret the output analysis, then we state that when we are studying the effect of the drug on the events, then we state that after adjusting for the effect of sex and age, those individuals taking drug B have 2.01 times hazard or higher hazard ratio to die from the cancer disease over time compared with persons in taking drug A. So this indicates that drug A is more efficient in prolonging life than drug B. And these findings are significant as the p-value is less than 0.05 and the hazard ratio fall between the lower value and the upper value for the 95% confidence interval, which double confirm the significance. For the risk factor, which is the sex or the gender, the way to write the results is to state that after adjusting for the effect of drug and age, there were no association between gender type and the risk of death over time. Why? Though the hazard ratio is 1.01, the p-value was greater than 0.05, so there was no significance here, and also the 95% confidence interval include in it a value of 1. So the gender, we can conclude here that gender had no influence on the hazard rate or death rate. So there is no difference between the rate of death for males or females over time. And finally, for the last risk factor, which is a continuous factor or predictor, after adjusting for the effect of the drug and the sex, age is not associated with the risk of death over time, as the p-value is greater than 0.05 and also the 95% confidence interval includes a value of 1 in it. So this states that the age has no effect on the hazard rate, which is the death rate.